So what we learned today, we reviewed some of the corrosive services. Different chemical environments need different resins. You can use different resins. You notice that the corrosion barrier has changed. I will say in a chlorine environment, the thicker is probably the better. You have to also realize though that the thicker the corrosion barrier, the harder it is to manufacture and the more time it takes to manufacture it, more time to do the tie-ins. So, and you get into some smaller vessels, it becomes even more difficult with the corrosion barrier because typically those tie-in joints have to be equal in corrosion barrier compared to the vessel itself. So unlike metals, operating temperatures specified can limit the use of FRP. I address this quite often. I get a lot of specifications that want to push above an operating recommended. We can go to the chemist and see if they're okay with it. But a lot of times if it touches 2 or 3 engineers along the way, that operating temperature increases, right? Everybody wants a little safety factor. And you have to realize that once we get within about 35 degrees, in fact, for some of the standards, if you're within 35 degrees, we have to take a real knockdown on the physical properties when we're designing this equipment. So be realistic about the design temperatures and realize that we're already taking safety factor on pressure and vacuum. So our factor of safety on pressure is usually 10-1, and on vacuum buckling is 5-1. So if everybody in the food chain's adding a little extra on top of that, we could get to the point where it's either over designed or we can't handle the temperatures, right?